All right, we're going to continue our factoring with special factoring. Special factoring usually always involves perfect squares. I'll encounter perfect squares, and in the first part, there's going to be a part A, and there's going to be a bottom part B, perfect square trinomials. We're going to start with difference of two squares. Notice that none of these problems in this first part of the lesson have no middle term. It's just x squared and 100. There's no middle term. Notice that the first one is a square, because I can break that down into x times x, okay? Also, 100 is also a square or a perfect square because I can break that down into 10 times 10. Now, I'm going to use those factors and those squares, and I'm going to recall that I'm not going to have a middle term, so it's going to be x and x. First one's in the parentheses, just like we practiced the last time. 10 times 10. Now these are exactly the same. I need to think about what do my signs need to be such that when I check this and I have 10x, and the other one's also 10x, they're almost identical, except I need one to be minus and one to be plus. If one's minus and one's plus, then what's going to happen is I'm going to end up with 0 x's, and 0 x's gives me no middle term. So these kind of have a pattern, and if you kind of see the pattern right away, these can be some of the easier factoring problems that we do. All right, so again, no middle term, check for squares, see if you have a difference of two squares. And when I say difference, it's got to be a difference, because a difference is the answer to a subtraction problem. So you got to have a subtraction sign in the middle. All right, checking number 2, I have a square in the front, x times x. I have a square in the back, 6 times 6, and I have a difference of two squares. So I think this is one of those special factoring cases where I don't have a middle term, so it's going to be x and x. 36 breaks down into 6 and 6, and I have no middle term, so I need one to be positive 6 and one to be negative 6. When I do my check step, I get 0x, and that's where my middle term is gone. So it's actually almost the same thing in parentheses, except for a positive and a negative. All right, this one the same thing. Do I have a square in the front? Yes, 4x squared can be broken down into 2x times 2x, and again, that's a perfect square. 81 is a perfect square of 9 times 9, and sure enough, I do have a subtraction sign in the middle, so I have a difference of two things that are square, a difference of two squares. So I'm going to put 2x and 2x in the parentheses. I'm going to break that down into 9 and 9. And again, no middle term means I mean 1 plus and 1 minus. That would give me positive 18x. This outer one would give me negative 18x. And sure enough, I get 0 x's. So 2x plus 9 and 2x minus 9. Again, these can be some of the easier factoring problems that we will do. Usually people get to catch on pretty quick. I'm going to pause the video. I want you to try these next two all by yourself. All right, back to the video. I did my you try problems. Here are the answers. Y squared is a perfect square, 64 is a perfect square, y plus 8, y minus 8. It doesn't really matter which one's plus, which one's minus, as long as you have the two parentheses there. Okay, 25x squared. 25 is actually a square. It turns into 5 and 5, so I'd break this down into 5x times 5x and 7 and 7. Again, plus and minus. So the difference of two squares, these are special factoring cases, can be some of the easiest ones. You have to recognize why don't I have a middle term. And the reason you don't have a middle term is because you got one positive and one negative, but other than that, the parentheses are almost identical. Now let's turn to perfect square trinomials. Okay, these will factor just like other trinomials, but we have a square in the front and a square in the back. Okay, the first one is x and x. 36 is 6 times 6. So if I break these down into just factoring my trinomial like I did in the past, I factor it to x and x, and I'm going to try 6 and 6. Now, what happens is the last term is positive, so I need to mentally add to get the middle term. So I want to add to get 12. Well, sure enough, 6x and 6x adds to give me 12. They're both going to be plus and plus. Now notice that I have two parentheses this time that are perfectly identical. Not one negative, not one positive, both identical. And so that's where I can just abbreviate this as x plus 6 quantity squared. This is a perfect square trinomial. So if you have this first and last to be squares, and you can mentally take these and help you get the middle term, then you probably have two parentheses that are identical. But again, just factor as normal, x and x, 10 and 10. This time I need to add to get the middle term, but this time I want to add to get a negative 20. So I'm going to need a negative 10 and a negative 10, so that when I check it, negative 10x and another negative 10x, sure enough, gives me negative 20x. So I have negative 10 times negative 10, or I can abbreviate this as x minus 10, quantity squared. And so these are perfect square trinomials. All right, let's look at example 3 and 4, because example 3 and 4, the first term is not something we've done any before. But if I check, first thing I'm going to do is say 4. 4 is a square. So if this is a square, and this back here is also a square, then it probably will turn out that that's probably double the middle term. Because if you go back up and we look closely, notice that 12 was double the factor 6. 20 was double the factor of 10. But this time I have 2 in the front and a 5 in the back. So if I break this down into 2x times 2x, and this goes down into 5 times 5, if you take one factor from here and one factor from here, 5 and 2x, so you get 10x and double it, you're going to have 20x. This looks like I'm going to have a perfect square trinomial. Let's just check. 2x, 2x, 5, and 5. I need to add because the middle term is or last term is positive. I'm going to add to get negative 20. I believe I'm going to need minus 5, minus 5. If you do that mental check step, you get negative 10x. You get negative 10x again. So when I was saying pick one of each factor and double it, it's kind of the shortcut that I had taught you back when we were multiplying. Sure enough, that does give you negative 20, and we can actually break it to 2x minus 5, quantity squared. Okay. 25 is a perfect square. 36 is also a perfect square. And so if I break it down into the perfect squares, I'm going to get 5x times 5x, and that's going to give me 6 times 6. Pick one of each. So I'm going to get 30, double it, I get negative 60. So yes, this is a perfect square trinomial. Break it down. 5x and 6, 5x and 6. And sure enough, I both have to be negative, negative, because that would give me negative 30x. That also gives me negative 30x, and sure enough, negative 60x. So check step is always a great way to mentally find out whether or not you're doing them right. Or 5x minus 6, since these are two perfectly identical or twin parentheses, 5x minus 6 squared. Now, pause the video. Let's let you see if you can find the two perfect squares, breaking them down in parentheses. Okay. Coming back to the video, I hope that you were able to factor 4x plus 5 and 4x plus 5. Again, do the mental check step, make the smile, 4x plus 5 quantity squared. The last one, it's a little easier numbers, x minus 3 or x minus 3 squared.